Hey everybody. I hope this is going to work. Now, if you weren't here, then let's see, today is Thursday. If you weren't here Thursday or Friday, October 1st and 2nd, then, is that right? Yeah. Then you didn't get to do the lab and collect the data yourself in class. So here's what we're actually doing. The file that I posted in the assignment tells you everything you're supposed to be doing in terms of collecting masses both before and after something happens. Oh, I need to shut my door. Hold on. Okay, so everybody collected all the data, and actually I am trying to create a spreadsheet in Sheets that I'm sharing in the assignment, a link that you can access and that everybody can put their data in. Because here's what I ended up doing first period. I ended up writing down all of this stuff, and then in the middle of it I thought I could probably share a sheet and then everybody could type in their own and it would save a whole bunch of time. So notice what I had here is I had a steel wool stretch section, a steel wool heated, a sugar, and then an Alka-Seltzer section. And I had BA before and after for each of them. And so that's what's in the spreadsheet. And it looks kind of like this. So this is what the spreadsheet looks like. And there's like groups 1 through 9. And so hopefully you'll know which table you sit at and how I had kind of numbered them before. If you don't, then I suppose, I don't know, we'll have to figure that out. But this is what you would be looking at and typing your numbers in, so we have a little easier time and actually faster to get all the data together. Now, once everybody got done with that and collected all the data, my question was this. You, with the person you were collecting data with, you were supposed to figure out a reason why the mass stayed the same, why it went up, or why it went down. So again, you're comparing masses before and after you stretched the steel wool, heated the steel wool, before you combined the sugar in the water, before you combined the Alka-Seltzer with the water, and then after. So again, the question that you had to answer in the lab is, oh boy, let's see here. Oh geez. Why, mass stayed the same, went up, or went down. So a reasonable explanation as to why your mass did what it did. Okay, so that's what the goal was here. You measure the masses of all 4 parts, and then you had to come up with a reasonable explanation as to why your mass did what it did. So that's that. Then I added this part here where they were supposed to sketch a particle diagram. And again, the rules for particle diagrams, let's go back here. The rules for particle diagrams, make it quick. Don't spend a bunch of time on it. Use colors or shapes, include a key, and title it. So those are the rules, again, for particle diagrams. And so I had the students talk about why they think the mass did what it did, and then sketch a particle diagram for the before and the after. Now, how on earth are you going to draw a particle diagram for steel wool? A little ball of steel wool. Well, here's how you don't do it, right? Do not do this. That is not a particle diagram, okay? That's like an actual sketch or drawing of what a steel wool ball would look like, a bunch of tangled fibers. That's not particles. That's a tangled fiber ball, which is what a steel wool ball is. So don't do that. So how would you draw a particle diagram for a ball of steel wool? Well, you draw a bunch of particles in the shape of a ball. So like this, maybe. I should title it though. I didn't do that yet. So you might do this. You might say on here, steel wool stretch. Those are the abbreviations I'm using, steel wool stretch. And you might have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20. Now, there's no significance to 20. It's just I drew enough to make it feel like that was, enough to show that this is a ball of steel wool. Now, what I haven't done yet, though, if you look at the rules for particle diagrams, so I have particles in there. I titled it steel wool stretch. Oh, I should probably say like before and after. This is before. You'll have an after picture as well. Now, I should probably have a little key here that says that my little circles here are steel wool particles. That way everybody knows that's what those are. Those are steel wool particles. It's a ball of steel wool. This is, maybe I could spell before correctly. Oh my gosh. Now, how are you going to draw the after? Well, then you got to think about, okay, what did you do to the steel wool? You fluffed it up, you stretched it out. So these particles then are really far apart, and you were supposed to make it twice its size. So that's how you would draw the particle diagram for something like the steel wool. Okay. Now, how would you draw a particle diagram for the vial? Because again, you're using vials like this. Okay. So you have this glass vial with a cap, and so how are you gonna sketch that? Well, I would do like this. So if you have maybe the sugar part. So if we have the sugar part, and again we have a before and an after, then you might draw something like this. So for a before picture, maybe you have this, and then you have little threads there, and then now some of you are like, I can't draw that. Oh, come on now. So you can probably draw that. So there's my vial, and then of course I have to have a cap. Yeah. So there's my cap, and so that would be it. You don't have to draw the vial and the cap as particles, just like I didn't draw the what's it called? The coffee can. I didn't draw it as particles. I drew the contents as particles, but I didn't even draw the flames as particles, just the contents. And so in this case, the same thing. Just the contents of your vial and your cap, those will be particles. So I shouldn't have drawn this blue, because what's in the vial? You're supposed to fill the vial about half full of what? Maybe I can use a different. Oh no. More. Oh boy. Oh no. Yeah, how about that? That'll work. So you're supposed to fill the vial with something about half full. So I might do this. It did it on the thing, but I didn't do it on the thing. Right there. Okay. 1, 2. What the? All right. That. This right here. I want that color. Oh my gosh, why is it not working? Why is it not working? What is happening here? More there. No. Oh, right there. Okay. So I now have another one. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Now, is there any significance to 25? No. That's just about how many it took for me to feel like it was about half full. So those are my water particles. How am I going to show you that? I put a key at the bottom and I say, hey, that is water. Now, what's in the cap? What were you supposed to have put in the cap? Sugar. That's why it's called the sugar part. And so how many particles of sugar do you think are in there? Do you think there's as much sugar in the cap as there is water in the vial? I hope you're thinking no, because that cap's small and you can't fit nearly as much sugar in the cap as what you can water halfway up the vial. So maybe it shouldn't be like if I had 25 particles of water in there, then I probably shouldn't have that many of sugar in the cap, just a few maybe. Okay, well then I need to change my colors because I can. If you don't have colors that you can change, then maybe you should use a different shade. So maybe I'll just show that there's 1, 2, 3, 4, 5. So maybe I've got 5 sugar particles in my cap. All right, that's my before. Now, how do you draw the after? Well, in the after, you took the sugar, you dumped it in the vial until it dissolved, put the cap on, and so your after picture is going to have the vial with the cap on it and the sugar where? In the vial. So that's kind of how the particle diagram thing should work. Okay? So for the 4 parts, you should have 4 different particle diagrams and a before and an after for each of them. And your particle diagrams should reflect and show how you answered this question. If your mass stayed the same, your particle diagram should agree with why you think the mass stayed the same. If the mass went up, then your particle diagram should show how it's possible or why the mass went up. If the mass went down, then your particle diagram should show the reasoning behind why your mass went down. So hopefully that makes sense. So that's what we were doing in class. Now again, at home, you're not going to be able to actually collect this data and do this, I don't think, unless you have vials and steel wool and Bunsen burners and Alka-Seltzer tablets lying around. I kind of doubt if you're going to be able to collect this data. But you'll see the data in the spreadsheet once people start putting it in. So, and then hopefully you'll start to see our conversation that kind of unfolded. Now I will at least start the conversation because we started the conversation today in first period. And so we started looking at the steel wool stretch first and how this group's, it went up. Group 2 stayed the same. 3 stayed the same. 4 went down by 100th. 5 stayed the same. Down by 200ths, down by 100th, down by 100th, and down by 200ths. Now, I was trying to get some reasonable explanations as to why things changed, went up, why they went down, or why they stayed the same. Those that said it stayed the same, some of them said, well, because we had the same thing that we started with, we ended with the same thing we started with, we didn't add or subtract any steel wool, so it's the same value. Okay. Let's see. This group, group 9, they said that theirs went down by 200ths, that they had noticed when they were fluffing the steel wool up, some fibers fell off, broke off, fell off during that part, and that's why their mass went down. And I said, well, that is a logical explanation. And so I asked, how did you show that in your particle diagram? They said, we drew less particles in the after because some of them fell off. Oh, so they're showing the mass changing by how they drew their particle diagram and the number of particles that they used to do that. This group was starting to say the same thing. It went down by 200ths. Now this group, it went up by 100th. This group went down by 100th, down by 100th, down by 100th. What we found out was that we're not sure if 100th changing by 100th is that much. I mean, it doesn't seem like that's very much, 100th. In fact, some people said that their readings were bouncing back and forth between 2 values, up 100th, down 100th, up 100th, down 100th, and then would finally settle in on one value. So we think that 100th being off by 100th, maybe it didn't really change, and the scale is not sensitive enough to give you a consistent value every time. And so maybe 100th is like, okay, it was the same. We'll just say that 100th is the same. But if it changes by 200ths, maybe that's significant enough that the mass is different. Hopefully that makes sense. So the people that had the mass stay the same, hopefully they're saying in their particle diagrams that they have the same number of particles before and after. And when the mass went up, maybe they're saying that there's more particles after than there were before. And then again, when the mass goes down, that there's less particles after than there was before. So we will continue to talk about the rest of these scenarios and why they went up or down the way they did, and hopefully come to some conclusion by the end of it. So that'll involve probably another video after we have the rest of that discussion in class, which will be either Monday or Tuesday, depending on who you are and which period you're in. So hopefully this kind of helps give you an idea of kind of where we're heading, what we started to do in class. Hope you're taking care of yourself. We'll talk to you later.